Hello students, and welcome to this lesson on chords and arcs. Our objective today is that we will apply theorems about chords and intercepted arcs using journal notes and practice problems. So the first thing that we need to do is actually define a chord, and we already saw this in our poster project. A chord is a segment whose endpoints are on the circle. So it's a segment whose endpoints are on the circle. And interestingly enough, this is actually kind of a large category of things. So there's more than one type of chord. So we have a special chord where if we pass through the center of a circle, and that's called our diameter. So our well-known length, called the diameter, is also a type of a chord. And a diameter is related to the arcs because a diameter will always split a circle into two semicircles. Then you have a more standard chord. So you have something more like this. And this is like a standard chord. And a standard chord will break it into a minor arc and a major arc. So this is my minor arc. And then up here, it'll be a major arc. And now that we've defined the actual object itself, we can start to make some theorems regarding these objects. So we can start making some truth statements using chords as an object. And so our first statement that we're going to make, our congruent central angles theorem, says that if central angles are congruent, then their intercepted arcs and chords are congruent. And what does this mean to us? Well, first let's break it down. If central angles are congruent, so we need at least two central angles and they need to be congruent. The simplest case for this is going to be if we have a center, let's just call it, I think it's about here. So we have our center and we have this pair of lines that, or our chords rather, which are going across the circle. Then what this is saying is that if the central angles are congruent, so if I have this here being true, about point O, and then we'll call this A, B, C, and D, then their intercepted arcs and their chords are congruent. So we can summarize this in this way. So if we have these points as allocated over here, we have A, B, C and D, and then you have the line AB, the line CD, the arc AB, the arc CD, then we would say that if the angle AOB is congruent to angle COD, then AB, the line segment AB, is congruent to the line segment CD, and additionally, the arc AB is congruent to the arc CD. Alright, so that's our first theorem. We're moving on to our next one. So we also have congruent chords and arcs theorem. So if two chords in a circle are congruent, then their intercepted arcs are congruent. So what objects are we talking about again? Well, if two chords in a circle are congruent, then the intercepted arcs are congruent. All right, so let's go ahead and see what this looks like. So we're talking about two congruent chords. So I'm just going to draw two chords which are congruent to each other. Those look pretty close. I'm just going to mark those to verify that we know that those are congruent. And we'll call those points AB, and then we'll call these points C and D. So what it means, intercepted arcs, is it means the arc CD and the arc AB. So those are the arcs that we're talking about. And those will actually be congruent to each other now as well. So we say if AB is congruent to CD, then the arc AB is congruent to the arc CD. So now it's becoming very important that we make sure that we use our proper symbol on top of our points, right? So it used to be sometimes we could get away with just writing, oh, AB for a line. But now we don't know if it's the line AB or the arc AB, so we have to make sure that we're using our symbol on top up here to help us out. All right, additionally we have our equidistant chords theorem, or equidistant chords theorem. And that states that if two chords are equidistant, or the same distance from the center, then they are congruent. All right, so again, let's break this down. So we're working with two objects, two chords, and we're working with the center. So that means that we'll need to have a center here. And as long as they're the same distance, then they will be congruent. So let's go ahead and mark our center. And let's get some chords in here. All right, I'll use that one and that one. And what we're saying is that as long as these chords are the same distance away from the center, then they'll be the same length. And it looks like I may need to redraw this second chord a little bit. That looks a little bit better, I think. All right, and what we're saying is that as long as this distance is the same here, then these two chords will be the same. So let's go ahead and give everything names, A, B, and then C, D, and we'll call this O, and these points where we are connecting will be called E and F. So we want to make sure that E and F are going to be the same distance, and then that will guarantee that our two lines will be, or our two chords rather, will be congruent to each other.